Hello everyone, I'm Dr. Himat Alisha. Welcome back again. I'm super excited to kick off this brand new video series on our project HRANK. In this series, I will be teaching you how to implement HRANK, a keyword extraction method for web pages using Python step by step. From absolute scratch, we will be working inside Jupyter Lab, making everything hands on and easy to follow. So, in this first episode, we will explore the online HRank tool and dive into the research paper behind. So, if you are ready to learn, experiment, and build something amazing, let's get started. A URL for the web page is like http then cs.uf.fy/himmat/hrank. So H stands for Himmat and rank is the ranking of the method and keyword extraction finding keywords from online web page. So first of all you have to insert a web page here as an input. This tool was made in 2019 around 6 years ago. So for example if I say bbc.com here and click go, it starts processing using document object model. Please make sure that provided English web pages, it doesn't work on other languages. So first of all, we will check the text, a complete text of the web page. If we can open, we have the same web page here that is open. So BBC complete text of the web page, clean text. So in our first step of coding in Python, we use scrapers to find the text of the web page, and then we clean using pre-processing step. Next we can see next button is frequency, a word, the frequency, how many times a particular word appears in the inside the text. For example, BBC appears 22 times, Canada appears like 18 times, ago is a verb, 64 times. So most frequent word is ago, HRS, US. So these are the words that appears in our web page. The frequencies are very helpful and handy as they will help to find the most important words. Next we have parts of speech taggings, that is called POS, using natural language processing. It gives you nouns, adjectives and verbs because we will be focusing on three parts of speech taggers for English language. So we will be utilizing only these nouns, adjectives, and verbs as a keyword. So nouns list we have BBC, home, news, word, news, like for example, and then we have adjectives like there are different adjectives. They are repeated here, but next we see the adjectives. Then we have verbs. We know, breaking, approach, collided, no, for example. And then we have the clusters from the words, list of the words. We have n number of clusters, like we choose 8 different clusters. So you can see 8 different clusters. Each cluster possesses different words. So for example, this is like cluster 1, news, day, minutes, January, and this another cluster which collects word a country names Canada, Europe, Washington, Gaza, Israel, Ireland, home, Africa. This is second cluster. We are using agglomerative cluster. unsupervised machine learning. Then we choose some threshold to find the keywords from those clusters. So these becomes the keyword finally. So we will have 10 different keywords for the same web page. We can choose a different web page, for example, usind.edu.pk. So same process, text, POS, clusters, and keywords. Now let's jump into the paper, research paper that we published in 2019. This paper title is HRANK, a keyword extraction method for web pages using POS tags. We were the three writers, me, myself, my supervisor, Pasifranti, and the co-supervisor, Dr. Usman Khan. So main contribution of the paper was using NLP, natural language processing, and then we use a document object model DOM, a tree structure that helps to find different tags using tree structure of the web page HTML. And then we use POS tags such as nouns, adjectives, and verbs. I showed you earlier in the demo. And our method was special because it was fast and it outperformed also CL rank, another related method, state of art method that was available in and the literature. It outperforms CL rank, text rank, and term frequency. Three methods we compare. We had a systematic review. This is overview of HRANK method. This is called workflow diagram of the uh, paper. So it is we just input as a web page and we just get a set of keywords in the end. So it follows a different stages, like number one stage is called pre-processing and next stage is called keyword extraction. In the pre-processing stage, we first initially download the web page complete using DOM and XPath. Then we filter the text using pre-processing, and then we just separate the POS taggers using NLP, natural language processing. Then we normalize the text using tokenize and after tokenization, we normalize using stemming and lemmatization. After that, we forward this normal text into the POS tagger again to separate nouns, adjectives, and verbs. Then we just input these all list of words to the keyword extraction portion where we count the frequency of the words individually. Then we just input those frequencies of the word to the most frequent, because we trim out the word having less frequency or one or two frequency. We just trim out, we just take maximum frequency out of the words. After that, we use a word net to find the synonyms for those words. For example, a particular word was used for example, internet and net can be used simultaneously, and car and cars can be used same way. So then adding synonyms for the word from the using word net. And then after that, we just compute similarities between the words. For example, car and cars can be used a single word. Then we find the similarity. Based on the similarities score of the word, we use clustering using agglomerative cluster. Then we separate the nouns, adjectives, and verbs. And after finding the list of different words, we trim them and then we select the keywords. We observed that a simple measured term frequency perform better than more complex methods. Of course, a term frequency is always much better because the higher frequent word are most frequent words and they can be a keywords for a web page. However, the combination of the nouns, adjectives, and verbs improve the performance when TF fails. So sometimes somehow TF fails and where the synonyms are utilized. So then the combination of POS words can improve the state of the art methods. We perform a different systematic way with a state-of-art methods, and our results you can learn from here, and the examples are given also here. And then the evaluation of method, we use three parameters: precision, recall, and F measure. We observe that our method is outperforming other methods, state-of-art methods. So now we jump into the second video, and we will start implementing this complete HRANK using Python and Jupyter Lab. I will teach you how to create a virtual environment and then starting your project. Thank you for watching.